We will now talk about the three-phase transformers. So the three-phase power is transformed by use of three-phase units. However, in large extra high voltage units, the insulation clearances and shipping limitations may require actually a bank of three single-phase transformers connected in three-phase arrangements then. So the primary and secondary windings can be connected then either in Y, delta configuration, so mainly then. This results in four possible combinations. Typically is the YY delta delta, Y delta, and delta Y. And here you can see a YY connection diagram. The YY connection offers advantages of decreased insulation costs and the availability of the neutral for grounding purposes. That is very neat. However, because of problems associated with third harmonics and also unbalanced operation, this connection is rarely used actually. To eliminate the harmonics, a third set of windings called a tertiary winding connected in delta is normally fitted in the core to provide actually a path for the third harmonic currents. This is known as the three-winding transformer. In this YY connection diagram, we can see we have the capital H and the capital X value. So the YY or delta-delta transformers, the markings are such that the voltage to neutral from terminals H1, H2 and H3 are in phase with the voltages to neutral from terminals X1, X2, X3 respectively. In the B picture here you have the alternate form of connection diagram. And then you have the dotted connection. You can see the dot is here and here. Then making a representation that they are in phase by doing this. Here's another way to represent them when you have connections. You can see the delta here in the ABC form. Could look something like this when you have in connections. And then in the Y connection, often represented by this. And then you have this set zigzag representation here. The phase angle between the high voltage and low voltage side often are using a clock number to different between them. So then between each hour of over here it's 30 degrees. So you have like a 30 degrees displacement for every hour. So for example, if you have the Y11 connection down here, we can see that 11 is here. Here you can see a schematic method of indicating winding connections of a three-phase transformer. So voltages here are shown for a 66 to 6.6 kilovolt YY transformer supplying a 0.6 ohm resistors of impedances. Okay, so it shows a balanced system in which each phase can be treated separately, whether or not the neutral points are connected. If you look down here on the voltage line to line, is 66 kilovolt, and the voltage line to neutral is 38.1 kilovolt on the Y connection. Here on the other side we have also a Y connection, but here we have 3.8 kilovolt on the line to neutral, and we have a 6.6 kilovolt as a line to line. We can then actually represent, if you want to transfer the impedance from low voltage to high voltage side, we can use then either the line to neutral here on the primary and on the secondary in square, the ratio in square, or we can add the same way using then the line to line representation both for the primary and the secondary as a ratio in square. We will have then the same value of the ohm. Here's an overview of the different typical connection method between the primary and secondary. So we have the YY, Y delta, delta Y, and delta delta. So the delta delta actually provides no neutral connection, and each transformer must withstand full line to line voltage. So the delta connectors, however, then provide a path of third harmonic currents to flow. This connection has the advantage that one transformer can be removed for repair, and the remaining two can continue to deliver three-phase power at a reduced rating of around 58% of the original bank. This is known as the V connection. So if one of those are taken out. So the most common connections is the Y delta and the delta Y. These connections are more stable with respect to unbalanced load, and if the Y connection is used on high voltage side, such as here, then installation costs are reduced. The Y delta connection over here is commonly used to step down the high voltage to a lower voltage, and the neutral point on the high voltage side can be grounded. This is actually desirable in most cases. In the delta Y connection is commonly used for stepping up to a high voltage. On the right hand side here of the table, of course, you can see the different equations you can use for the different types of topology of the transformers. So if you have this YY, you can use those relationships you see here. However, you should see that this set L, the impedance of the load, will be the same representation on all of these 4 types. But be sure when you are calculating in examples, just to go here and see if you are can follow these different relationships here. Now, as an exercise, you should please try to go through the example 3.8, which is a 3 transformer, each rated 25 MVA. It's connected in Y delta with a balanced load of 0.6 ohm Y connected. So it's the same as earlier in the text. So try to go through that example now.